You know, every single day we're sending messages, streaming videos, doing all this stuff that feels like actual magic. But it's not magic, right? It's this incredible, brilliant system working just behind what we see. So let's pull back that curtain and figure out how the internet actually works. Okay, just think about it. The last email you sent, you hit send, and boom, it's there. It's just gone. But how? How did it actually get there? How does a simple message travel from your screen across oceans and continents and land in someone's inbox in like a second? Well, we're going to follow a tiny piece of your data on its absolutely incredible journey. So at its very core, the internet is just one gigantic computer network. And what's a network, really? Well, it's just a system that lets devices share information. Think of it exactly like this: a group of friends passing notes to each other. I mean, it's that simple. And that simple idea, it's the foundation of literally everything we do online. Right, but this whole note passing thing, it isn't total chaos. It's not a free-for-all. To make sure every single message gets to the right person and doesn't get, lost or all scrambled up, there are some very clear rules. It's kind of like a digital highway code that every single piece of data has to follow. No exceptions. And get this, those rules kick in before your data even leaves your computer. It has to be prepared for its big trip. The best way to think about it is like a digital assembly line. Your message gets packaged, it gets addressed, it gets inspected, the whole 9 yards. And it's this structured process that makes sure everything just works. So what's actually happening on this assembly line? Well, first up, packaging. Your data, whether it's an email or a photo, gets broken down into these small, manageable chunks called packets. Then, addressing. Each one of those little packets gets a destination address slapped on it, just like a letter you'd put in the mail. After that, path selection. The system figures out the best, most efficient route for it to take. And finally, reliable delivery. There are all these checks in place to make sure every packet arrives safe and sound, and that they can be put back together in the exact right order on the other end. Pretty smart, huh? Okay, so our little data packet is all packed up and ready to hit the road. It's time to start its epic journey. Now, the very first step is figuring out two absolutely crucial things. Who is sending this data, and where in the world is it supposed to go? And to do that, you actually need two totally different kinds of addresses. First up, we've got something called the MAC address. The easiest way to think of this is like your device's fingerprint or a permanent serial number that was stamped on it at the factory. It's totally unique. Its job is to identify your specific device on a local network, so like your home Wi-Fi. It basically answers the simple question: who is sending this? But for the big global journey across the internet, you need something different. You need an IP address. Now, unlike the permanent MAC address, your IP address is temporary. It's kind of like being assigned a PO box or a street address by your internet provider. And this address tells the rest of the internet the most important piece of information. Where is this packet going? So let's just break this down real simple. MAC address? That's the who. It's the permanent ID of your device, perfect for local travel, like inside your house. IP address? That's the where. It's the temporary location out on the big network, essential for global travel. And here's the bottom line. You need both. One tells you who sent it, the other tells you where it's going. Simple as that. All right, so our data packet is ready. It knows who it is, and it knows where it's going. But now comes the hard part. It has to navigate this massive global maze we call the internet. I mean, how on earth does it know which way to go? Well, this is where the unsung hero of the internet comes in, the router. A router is basically the GPS and the traffic cop of the internet all rolled into one single device. It sits at all these digital intersections, looks at the IP address on every single packet that zooms by, and makes a split-second decision about the best, fastest path for it to take to get to the next stop on its journey. It's doing this millions of times a second. But wait a minute, that brings up a really good question, right? Because you and I, we don't type a long string of numbers into our web browser. We type easy-to-remember names like google.com. But the routers? They only understand the numbers, the IP addresses. So how does that translation happen? How do we get from our words to their numbers? The answer has a name. It's the Domain Name System, or just DNS for short. And you can think of it as the internet's giant address book. Seriously. When you type in a website, your computer shoots a message over to a DNS server and says, "Hey, what's the number for this name?" And the DNS server looks it up and sends back the correct IP address. It's the critical translator that connects our world with the computer's world. So, there you have it. That's the incredible, hidden journey that your data takes every single day, millions of times over. But here's the thing. This system is never, ever standing still. It's constantly being upgraded, rethought, and totally reimagined. So that begs the question, what's next? Let's take a peek at the future of how we all connect. Yeah, that invisible superhighway we've just been talking about, it's basically always under construction. Right now, engineers all over the globe are working to make it faster, way smarter, and able to handle just an insane amount of traffic, especially as more and more of our devices come online. So what does this future actually look like? Well, for one, you've got 5G, which promises speeds so fast they're basically instantaneous. Then there's the Internet of Things, the IoT, which is all about connecting everyday objects, from your car to your coffee maker to the internet. We've also got cloud networking, which is completely changing how businesses are built and run. And maybe the wildest one, AI and automation, are creating networks that are so smart they can manage and even heal themselves. I mean, every single one of these is a massive game changer. And this isn't just, tech for the sake of tech. There's a really great line in the source material that sums it up perfectly. It says, these advancements are playing a crucial role in shaping our digital future. They're literally building the foundation for innovations we probably can't even imagine yet. So think about how far we've come. We started with this simple idea, right? Friends passing notes. And now we're looking at a future of self-healing networks and a world where pretty much everything is online. As billions, literally billions, more devices join this global network, it really just leaves us with one huge final question to think about. How is our very idea of what it means to be connected going to change forever?